Hi, Accelerated Algebra 2, start here. So we're going to talk about some linear programming. So this is just some review stuff. I need you go ahead and ignore this. We don't need to deal with that right now. We're going to deal with making some inequalities based off of the word problem. And we're not really going to work out these in great detail at all. We're just going to set up constraints, and we're also going to set up something called an optimization equation, but we're not solving anything other than writing out the equation. So this first one talks about skateboards and scooters. So just to make it a little simpler, I'm going to call skateboards X, and I'm going to call scooters Y. Okay? Because if you just use S, then you don't know which one you're talking about. You can devote up to 20 hours per week manufacturing, 2 hours per scooter, and 5 hours per skateboard. Up to 7 hours a week has been allocated to detailing, 1 hour per scooter or skateboard. Minimum 8 hours per week is spent on customer service, 2 hours per scooter, 1 hour per skateboard. So write the 5 inequalities. Okay. So when you deal with these kind of things, you're always going to have these as your first 2 inequalities, which basically means when you're graphing it, your graphs are going to happen up in quadrant 1, okay, with the XY axis. Okay, that's why you do that. Okay, so those are our first 2 inequalities. So now I'm going to take the skateboards. So they tell us that 2 hours per scooter, 2 hours scooters Y, and 5 hours per skateboard. Skateboard is X, and we had up to 20 hours per week, so less than 20 hours. So that's our next equation that we would graph, but we're not graphing these, so don't worry about that. And then it says, as far as detailing, it takes 1 hour per week for each, and we have 7 hours worth of detailing. So 1x plus 1y is less than 7 hours. And then, so now I have 4 of my equations, and there's one more. There's the 5th one. And then it talks about customer service. So we have a minimum of 8 hours a week for customer service, 2 hours for scooters. So again, scooters are Y, and 1 hour for skateboard, so 1x. And we have up to 8 hours a week on customer service. So all of these, this is one of our equations, this is the other, so you got 2 of them right there. This is our 3rd one, and our 4th one, and our 5th one. So those are all of our things. What would basically happen if you were to work this problem out? You would have lines intersecting on the XY axis if you had graphed them, and they would deal with shading regions. But we're not dealing with that at this point. We're just creating the equations. Our next slide, this is talking about a bakery is making whole wheat bread and blueberry muffins. So for whole wheat bread, we're going to go ahead and call whole wheat bread, we're going to call that X, and then we're going to call blueberry muffins, we're going to call that Y. Okay? For each batch of bread, they make $35 profit. So now we are making an optimization. We're talking about a profit. Okay? So we have a profit equation that we're going to put in. This profit equation would not be graphed if we had graphed everything. We would actually plug the corners in, but we're not going to be dealing with that at this point. So it says for each batch of bread, they make 35 profit. So 35x plus, and for each, and then they make $10 profit for each batch of muffins. Okay, so that would be our optimization equation. That's a profit. Okay, sometimes there's a cost, so it would be cost or profit. Now let's create our constraint. So we know that we're going to have x is greater than 0 and y is greater than 0. Okay, again, we're going to make something. So those are our first 2 constraints. So then from there, it says the muffins take 0.5 an hour to prepare and to bake, and the maximum preparation time is 16 hours. The muffins, an hour to prepare and 0.5 to bake. Okay. I just lost where I was at. Oh, I'm sorry. So we have prepare is going to be 1, and then let's see with that. So that was the muffins. The muffins are, blueberry muffins are going to be Y. And then the maximum preparation time is 16 hours. The maximum baking time, is 10. How many batches of bread can we make muffins? Okay, hang on. Oh, the bread takes 4 hours to prepare. So the bread takes 4 hours to prepare, so that's X. So I'm going to go 4X plus 0.5Y. And we only have a total of for baking, where is that? Maximum preparation time is 16 hours. Maximum baking time. Okay, so we're on the prepare and the prepare. So if we're on the prepare for both, the maximum baking time, the maximum preparation time is 16 hours, so less than 16 hours. Okay, and then I'm going to look at my other part. It takes 0.5 to bake our Y, and it takes 1 hour to bake our X. Okay, so 0.5 Y, I guess I could flip-flop it. Let's just do it this way. And then 1 hour to bake, so 1X. And we have, how much time do we have for baking time? Looks like we have 10 hours, so it's less than 10 hours. So how many batches of bread and muffins should be made to optimize the profits? Okay, so those equations, if we were to graph them, they're going to work pretty nicely. I'm actually going to switch the computer over to something, but I need to pause this because I need to grab a pen. As you can see, I brought up an equation, something called Desmos. This is a free graphing calculator that you can get to online. So let's take a look at our equation. So we're going to plot our constraints. So we have Y is less than, oops, shifted that, is less than, or excuse me, Y is greater than 0. Hit enter, and we're going to go X is greater than 0. And then I'm going to plot my, the nice thing about Desmos when we do this, and again, you just go to desmos.com and start graphing. And then I'm going to plug my two equations in. So I have 4X plus 0.5Y. And that is less than 16. So notice it's really graphing over the top. And then my other equation, hit enter after that. My other equation is 1X plus 0.5Y is less than 10. So notice, I'm going to drag this, and I'm going to come out a little bit. So notice we have this region right in here. So I have that point there. I have that intersect point there. If you put that point, and then I have this point here is also what we're using. And then I have the 0, 0. So that makes this four-sided object. Okay, this four-sided object here is what we're going to deal with. So I'm going to come back to those numbers in a sec. I just have to write down those numbers on the sideboard, and I'll bring them up to the smartboard. So I have 0, 0. I have 0, 20. I have 2, 16, and then I have 4, 0. Those are my four corners. And I just wrote this on the board next to me, which you can't see, but I'm going to look at it for some detail later. All right. From there, I'm going to go back to my equation. So remember, we made that profit equation originally. Okay. So if I scroll my board down a little bit, if I plug, using this equation here, if I plug 0, 0 into it, I get P equals 35 times 0 plus 10 times 0 is equal to 0. So if you make nothing, you don't make any money. Duh. So let's not use that point. Then let's use point 0, comma 20. Okay, so my profit is going to be 35 times 0 plus 10 times 20. And that's going to give me 35 times 0 is 0, 10 times 20 is 200. If I add those together, I wind up with a profit of 200. Okay, now we're making money. I like it. And then I'm going to plug in the point 2, comma 16. So I have P equals 35 times 2 plus 10 times 16. So 35 times 2 is 70. 10 times 16 is 160. 70 added to 160, I believe that is 230. So it looks like I'm going to make even more money if I do 2 of one and 16 of the other. And then my last point is the point 4, comma 0. If I can again use my profit equation, 35 times 4 plus 10 times 0. 35 times 4, I believe, is 140. Yeah, that works. And 10 times 0 is 0. And that's going to allow me to have a profit of 140. So my maximum profit I can make is $230. Okay, so if I made 2 of my X's, what are my X's? My X's were whole wheat bread, so I made 2 whole wheat breads, and I made 16 of blueberry muffins. I'm going to have my maximum profit. So this would be something that a business definitely look at doing this kind of stuff. Okay, that's a tougher question. Happy to go over questions with that when we're in class, okay? All right, this last one, it talks about a factory makes fruit-filled breakfast bars and granola bars, okay? So we're going to call the breakfast bars, we'll call those X, and the granola bars, we're going to call Y, okay? For each case of breakfast bars, the company makes $40 profit, okay? And for each granola bars, they make $55 profit. The table below shows the number of machine hours and labor hours needed to produce each type of snack bar. It indicates the maximum number of hours available, okay? So we make, let's make our optimization. So we're profit. So we make 55. Our breakfast bars, we make 40, so 40x, plus 55 of the granola bars. Let's just make sure I had that right up above. Breakfast bars X, granola bars Y. Yep, we did that right. So that's our profit. So now we're going to create our constraints for this. So remember, our first ones are X is greater than 0, Y is greater than 0, because we're only dealing with quadrant 1. Now the first one talks about the machine hours and the labor hours. So remember, we call the breakfast bars X, granola bars Y. So then I have 2X plus 6Y, and I'm getting that from these values, is less than 150. And then I get 5X plus 4Y is less than 155. So if I plot all of those, we can do that. It says, it indicates, it says that on our thing, says the table below shows the number of machine hours and labor hours needed to produce each type of snack bar. It indicates the maximum number available. So we do have the profit equation already written. We could go ahead and plug that into Desmos, which is pretty cool. And I know it doesn't ask for it, but let's find out because we have the equation there. So I'm going to go back over to Desmos. And again, it's just desmos.com. And I'm going to keep my first 2 equations because those are vital. And then my next equation is going to be 2x plus 6y is less than 150. Yep. 2x, plus 6y is less than, we said 150. Cool. So that's going to give me in another corner. Create the new equation. And then we have 5x plus 4y is less than 155. All right, so now if we take a look at this, this is all drawn for us nicely. Let's find our corner. So we have a corner here, that's 0, 0. We have a corner up here, which is 0, 25. Corner here at 15, 20. and a corner here at 31.0. Okay, so I'm going to write those off to the side. Of course, you can't see it because I'm just writing down on my board. So we have 0, 0. We have 0, 25. We have 15, 20. And we have 31, 0. So if we plug those values back in on our equation, using our profit equation that we created, we can go ahead and do that. All right, so I'm going to scroll this down. Extend the page. And let's extend it one more time. All right, so we're going to use my 0, 0 for the first one. So if I plug 0, 0 into my profit, that's going to give me 0, and that's what you would expect. Let's try the 0, 25. And I'm going to use my calculator. 55 times 25, I don't remember what that is off the top of my head. So 55 times 25, 1375. That's pretty good profit. I kind of like that if I was a business owner. And then I'm going to use 15, 20 as one of the other corners. And let's see, I can't do that in my head, sorry. So 40 times 15 plus, what was the other one? 55 times 20. That's going to give me 1,700. Hey, I own this business. Now I'm going to make 1,700. Now we're talking. And then we want to check our last corner, which is 31, 0. So 40 times 31, again, I got to use the calculator. 40 times 31 is 1,240. So this gives me my most amount of profit. So if I make 15 of the breakfast bar batches and 20 batches of my granola bars, I would have the most profit. So again, the company would love that. And again, I know there's going to be questions about this, and I'm happy to answer them when we're in class. So have a great day, everybody. Take care of one another.